wander around while you work this. I want to see what you guys get. Yeah, great start, great start, great start. Yeah, we're finding a lot of important pieces in here. I've seen a lot of people with some really good important things noticed. Let's just start with those equations. All right. So I've seen a few really awesome thoughts on things. I've seen some people circling stuff, saying we know that this is our, ooh, that is a chunky pen, holy cow. Noticing that this is our total. I've seen people saying that we have maybe X for the washer. Oh, that is really hard to write while walking. But I gotta close my door. There we go. Maybe X is my washer and Y is my dryer. The way we know that those are going to be what our variables are is it says find the cost of each. It means I don't know the cost of either one. And they cost different things, so I've got to put them as two different variables. So how could I smush those things together to make an equation? X plus Y equals 1,500. That's exactly what I was thinking. So switch this. My washer and my dryer combined together makes a total of 1,500. I saw that on a lot of people's pages, not everybody's pages, but most pages had that. Or at least some piece of this. The second equation in this one is a little bit more finicky to wrap your brain around. What do we know? What else do I know that can help us figure this out? The washer is 200 more. And I'm going to do...
I don't understand.
I wasn't talking to you. Oh my gosh, she's so nosy. I'm going to do this way. So we have that the washer is 200 more than the dryer. Helps if I fit all the words in. More than dryer. So what we're going to do is I'm going to take this little sentence and we're going to kind of turn this into an equation for us. So the washer, what were we calling the washer in our equations? X. What's a math word for is? If I say X is 27 equals. So X is, my washer is, 200 is a number. I'm going to come back to that more than in just a second because it's not a greater than. My dryer, what were we calling that in my equation? Y. What is this more than in relation to these here? Plus. My dryer plus 200 is the cost of the washer. Or the washer minus 200 equals the dryer. You can do it either way. So you can straight up take these sentences that talk about the relationships we have and do it like a translation. If you think over to a foreign language class, you can do it like a translation from English into math. It works the same exact way. So then what we're going to do is we're going to solve this and figure out my solutions. What method of solving are these two equations set up well for? Substitution. I have an x equals meh. So we're going to go ahead and do some substitution. I'm going to give us some space. Ew, I hate that so much. Okay, that's less awful. I'm going to substitute in this 200 plus y in place of the variable x. So when we have our x plus y equals 1500, we're going to really be putting our 200 plus y in place of that x plus y equals 1500. We're substituting that piece in place of the x. Walk me through the solving part here. Yes, dear. Combine like terms. So I've got 200 plus 2y equals 1500. What next? Get y by itself, specifically. Subtract 200. And we get that 2y equals 1300. Sweet. What next? Divided by 2. We're just all over the place with these colors right now, and that's okay. So we get that y is what? 650. What does that tell me again? How much the dryer costs? My dryer costs $650. How much does the washer cost? $850. How do we know that? Yeah. You can either substitute that $650 in here or in here. $650 plus 200 gives us $850. That gives us the cost of both appliances. That is not an 8. There we go. So these story problems have kind of kicked us in the teeth for forever. So we're going to practice working with these words, finding the equations in the sentences. Because they're there. They just look weird. Questions on this one? Cool. We're going to go number 3. It's going to feel real geometry. We've got 2 angles are supplementary if the sum of their measures is 180. So if one angle's measure is 90 more than twice the measurement, what are the measures of each angle? Gross. First things first, what are we looking for? What do we know? What do we know? What's the question here? What are the measures of each angle? So what that means is I have 2 angles, and I'm going to come up with a name for them because I don't like to say the first angle and the second angle because that gets really annoying. So you could call them angle A, angle B. You could call them angle X, angle Y. Call them angle Bob, angle Fred. I don't care. Doesn't mean anything. They're not real angles. They're theoretical. So I'm going to call them, and if you're feeling real fancy, that's the sign for angle A and angle B. We're just going to use the A and the B in the equations because don't put that symbol in an equation because, ew, we're going to think it's a less than. And I want to know what each of them are. So, first things first, I'm going to come in here into a sentence and find out one piece of information. The 2 angles are supplementary if their sum is 180. How could I say their sum is 180? 180 is my total for sure. Let's see, I'm going to change how I highlighted this. The sum of, ooh, holy cow, not the pen I wanted. The sum of their measures is 180. So is 180 for sure means equals 180. What equals 180? Their sum of their angles. What are the measurements of the angle? We're just going to put A and B. So my two angles, the sum plus of their measures, A plus B, is equals 180. Blah. The sum means plus of their measures, A plus B. So it's all about finding pieces in there. The second one is more annoying. So one angle, oh, that's not what I wanted. So one angle's measure. So we're going to pick one, A or B, doesn't matter which one. Is. So which one do we want to pick? One angle's measure is. I don't care. B? I think I heard that. So B is. One angle's measure is. It is. 90 more than. How can I put 90 more than? 90 plus. Then we're going to go twice the measure of the other. Yes, good catch. Twice the measure of the angle we weren't talking about. Yes. We're looking for the pieces in the sentence that work as mathy things. That's all it is it's more of a translation. It's almost like a foreign language. And finding those pieces is obnoxious. But that's the important part. When we're solving these systems, the more we go through this chapter, we're going to get pretty good at the arithmetic part. And it's you got to slow down to write the equation right before we start whipping into the solving stuff. Because how are we going to solve this one? What's this one set up really well for? Substitution. Because I have a B equals. B equals this. So I can take this and substitute it in and get that A plus 90 plus 2A equals 180. And we can solve this. What do we do next? Combine like terms. Boop. So I wind up with 9. Ooh, that's the wrong pen. 90. That's not doing what I wanted it to. There we go. Plus 3A equals 180. Then what? Minus the 90. So 3A equals 90. A equals 30. So angle A is 30. What is angle B? 150. We take that by substituting it back into one of our equations, or here or here. A plus B equals 180, or B equals 90 plus 2A. Same dealio, you'll get the same answer. Looking for those places where it's crossing. all about finding the pieces we need in the story. And that's not easy. That is one of the hard parts of these systems, is the stories. Questions on this one? Cool. Because now we're going to move kind of in a different direction. This is page 46. And what we're asked to do is we're going to look at this equation. They gave us 5x minus 2y equals 3. And we are going to write a system that meets these qualifications. And there's 4 pieces that we have here. And I hate that I have them on 2 different slides. So I'm going to fix that real quick while I talk. So I want to be able to write a solution, or write a system that's going to have a solution. Meaning my 2 lines are going to cross. I want to see if I can write a system with no solution. That's one of our things. I want to see if I can write a system with an infinite number of solutions. And I want to see if I can write a system with 2 solutions. Those are my options here. All of them related to this equation here. The 5x minus 2y equals 3. What does it mean for it to have like an infinite number of solutions? What's that going to look like? Or what's that going to feel like? Or how about a no solution? What's that one going to be like? What does it mean if they have no solution? A system. What you got, Amber? Right. When we're going through and solving, we get something like 3 equals negative 3. That is a great example. What about, so it's unsolvable for sure. If I was to graph it, what would it look like? Go ahead, Amber.
You would basically graph 2 things, but they would never cross.
They would never cross, never ever cross. What is it called when we have 2 lines that never ever ever cross? Parallel lines. So these are parallel lines. Do you know what, remember what it takes for them to have parallel, for 2 lines to be parallel without having to graph them and see? This is same slope, different intercept. I'm going to just put different beat. How about for our infinite number of solutions? What's that like? What does that mean? Go ahead, Amber.
Basically, with infinitely many solutions, your answer would be 0.
Yeah, when you solve it down, it solves forever. Solves to truth. What does it look like? There's a V in the word solve, and I totally did not put it in there. There we go.
Basically, when you graph,
Mhm.
both of them are on top of each other.
Yeah, it's the same line twice. Usually in a different form. I'm going to give us a space here. So when we're looking at these kind of write the system things, if infinite is one of your choices, start there. Because we're looking for the same line twice. It just means switch it around a little. Let's put it in slope-intercept form. It's the same thing. Can I zoom it in? Okay. We're going to extend it down. There we go. Just so I have a little space to write. So let's look at our equation, which helps if I can see. So we're going to take our 5x minus 2y equals 3. And let's put this in slope-intercept form. Meaning, let's get my y all by itself. What's going to be my first step to getting y all by itself? Subtract both sides of 5x. Minus 5x, minus 5x. It's going to leave me with minus 2y equals, and since we're going slope-intercept form, I'm going to take this minus 5x and put it in front of the 3. So we have mx plus b. So we have minus 5x plus 3. Because I can't combine those together. Then what do we do to get our y all by itself? That's my goal still. Divide both sides by -2. And you can either do this with one big division like this, or you can divide individually like this. It means the same thing, as long as you get to all the pieces. Either way is fine, whichever way works better for your brain. This way works better for my brain, but that's me. And if you like the minus 5x plus 3 all divided by -2, totally cool. Means the same thing. Same dealio. Don't do both. Just whichever side works better for your brain, do that. Because we still need to simplify this. Because we're going to wind up with our y equals, what's negative 5x divided by -2? What does that simplify down to? What does this simplify down to? 2.5, or 5/2. The negatives are the only thing that drops. It doesn't matter. If you like decimals, go with that. If you like fractions, go with that. Totally fine. So since we're keeping this one in decimal, we have 2.5x plus 3 divided by -2, which means we're going to have minus, what's 3/2? Yeah, minus 1.5. So thinking back up here to my infinite number of solutions where we have the same line, it just looks different, we can put our slope-intercept form here. So that's how we find something with a system that's going to have an infinite number of solutions. If we think about our graph here, our negative 1.5 up 2.5 over 1 something, so it's going to be something steep like this. Just as a little sketchy sketch, something like that-ish. And our infinite number of solutions, there we go, just making it chunky. Our infinite number of solutions means this guy is going right on top. For our no solution, we've already said a few things here. We want something parallel, which means it can be lower, it can be higher, but it needs to have that same slope. There are quite literally an infinite number of options here. It just has to meet a few qualifications. It needs to have the same slope. So we can take it from our slope-intercept form here. If we're writing our no solution system, we're going to have our y equals 2.5x. And then this is where you get a little creative freedom. Put whatever you want as your b-intercept. We need the same slope, and that's it. Don't put negative 1.5. As long as it is anything other than 1.5, you're good. It can be negative 1. It can be negative 2. It could be positive 497. It could be negative 4,823,900. It don't matter. As long as it's not negative 1.5, you're good. So you could put plus 0. I'm going to go with plus, let's go 3. I'm just feeling 3 right now. Which means if we were to graph it, my little sketchy sketch here, avoiding my equation line. It's somewhere right there. I'm going to pop all the way back up to the top here for a second and look at one solution. How could I write a system with my big bold black line down there that has one solution? What does it look like when it's one solution? Let's say it again. You could do an x equals. That's totally fine. You could do a y equals. If I was to just, I'm going to grab a yardstick real quick. If I was to just hold something up to my picture here and say, how can I make it cross one time on my black line here? Pretty much as long as we're not here, it's gonna hit, right? So you can write whatever the heckin' line we want. Even if it's up here, it's gonna cross eventually. Even if it's way over here, they're gonna cross eventually. As long as it is not parallel, you can write any the heck equation you want. We're not asked to solve it here. We don't gotta solve it all the way down to a point. Driver's choice, man. You could do a standard form. You could do, I don't know, 10x plus 3y equals 27. You could do a y equals mx plus b. You could do y equals 27x minus 4. Or 1/3 x plus 7. Or negative 2/5 x plus pi. It genuinely does not matter. There are a few lines you can't write, meaning it can't be parallel and it can't be the same. So as long as it is a different color, oh, wrong pen. As long as it is not parallel and not equivalent, the world is your oyster. You could do y equals, let's go with 7/5 x minus 29/4. Just making stuff up. As long as my slope is not the same, we good. That's all we need. You don't have to go as extra as me. Y equals 4x plus 2. Exactly as valid. The slope is not the same. As long as the slope is not the same, we're there. Questions on any of those three before we get into this second one, which is not just weird. Okay. That's when we're going to use my little visual aids here. Got my 2 yardsticks. We agree that this is a line. We agree that this is a line if you ignore the hill on my sword marker. Is there any way, so we're going to pretend that this is my line on the equation, that I can get my 2 lines to cross and only cross twice? Can I bend this in any way to make them cross twice? What do you think? I'm make this with my line, just so that I can watch it. Is there any way I can make these cross twice, only twice? I can do an infinite number of times. That's this right here, where they're parallel, or where they're the same thing. I can make them cross never, where they're parallel. Can I ever make them cross twice? No, I can't. So writing a system where there's two solutions is not a thing while we're in linear systems. For it to have two solutions, we would need it to have a curve. I would need to be able to bend it. I really like to my stomach. I need to be able to bend it, like this, where we had a parabola. Then I could have two solutions. I can almost reach it. But that's not what we're working with right now. We're working with lines. And I can't make that happen with lines. So the two solutions thing does not work. That's why they tossed in this random line up here that says, if possible. This is not possible with lines. So if you ever have a system that says, write me a system that has two solutions, can't do it. Not a thing. Not until we get into our parabolas and stuff, and even then we're not going to do it like this. Because ew. Okay, questions on these guys? I kind of smushed it all onto one page here, but that's all of that whole page for you. Okay. That's the second part of that page. All right, you guys now have everything you need to do homework 2, which you don't remember the page numbers for, but it is up on Canvas with the page numbers. They are in your book again. I'm just going to pull it up real fast to see if I can do that. Because I genuinely don't remember, and that is not the current year's book. Skip. There we go. It's one of the ones on page 45 and page 47. So page 45 and 47. 45, number 5, not number 4. Number 4 is the gross one from yesterday. Just making sure. That's not the gross one. I'm pretty sure I did. Yeah. Okay, so you guys have about 10 minutes in here to work on this. Tomorrow we're going to do one of those card sortie things. And the only other assignment this week is the e-learning assignment on Thursday. Okay? So pretty chill. I'm going to write the page numbers up there. But other than that, you guys get the rest of this time to work on stuff. The AirPod case just fell. I don't want you to lose it.